All right, here's solutions for written problem 2, the first, I guess, real written problem for this class, where we are dealing with an exponential function. So it tells us f of x equals a times b to the x power, and we're told that f of -1 equals -3 and f of -3 equals -48. And the first thing to do is to determine the equation of f. And the way you can do that is, well, if f of -1 equals -3, that tells us that when x equals -1, y equals -3. So I can kind of rewrite this equation, but in place of y, the f of x here, I can write -3, and in place of x up here, I can write this -1. Similarly, if f of -3 equals -48, that tells me that -48 is equal to a times b to the -3rd power. What I can now do is take these two equations and divide them. And it's beneficial to take the one with the larger exponent on b and make that the numerator. So while you don't have to do it this way, I'm going to take this equation and divide it by this equation. So this -3 over this -48 would be equal to this ab to the -1 divided by this ab to the -3. And the negatives cancel out here, so I get a positive, and 3/48 is the same as 1/16 if you reduce those fractions. And then the a's cancel out, so I'm left with b to the -1 over b to the -3. And there's a variety of different ways you can get to calling this b squared. You could say -1 minus -3 is the same as -1 plus 3, which is this 2. You could also rewrite this b to the -3 as b to the +3 up on the top here. And then b to the -1 times b to the +3 gives you this b squared. One way or another, you'll get to this equation. But we don't want b squared, we want b, so we take the square root of both sides of the equation and get that b equals 1/4. And if you're really clever, you might be like, technically, b could be 1/4 or -1/4, and it would satisfy this equation. However, we assume that b is greater than 0, so our value of b is +1/4. And once we have our value of b, it's fairly easy to get our value of a. We can just plug it back into any one of these equations. This one appears to have smaller numbers, so I'm going to use this one. I'm going to say -3 equals a times 1/4 to the -1 power, copying exactly what we see here, except with the 1/4 in place of b. And then I'll recognize that 1/4 to the -1 power is the same as 4, because raising something to the -1 power means taking its reciprocal. So I have 4 times a, and if I divide both sides of the equation by 4, I get a equals -3/4. And now that I know a and b, I have my answer to 1, I have my equation for f. I can say that f of x is equal to -3/4 times 1/4 raised up to the x power. And now that I have 1 done, 2 and 3 won't be too bad. For part 2, all I'm supposed to do is evaluate f of 1/2. Well, f of 1/2 is just taking my function f of x, which is written right here, and copying exactly what I see, except changing all the x's into 1/2. So I would still have this -3/4, and I would still be multiplying that by 1/4, but now the exponent that I'm going to raise it to will be the 1/2 power. And so really where the challenge comes in is you got to figure out, what does it mean to raise something to the 1/2 power? Well, raising something to the 1/2 power means taking the square root of that something. So I need to figure out what is the square root of 1/4. And it turns out the answer to that question is 1/2. And there's at least 2 different ways you can get there. Either you can ask yourself, what number, when I multiply it by itself, gives me 1/4? Well, 1/2 times 1/2 gives me 1/4. So the square root of 1/4 is 1/2. Another way you can get there is you can say the square root of 1/4 is the square root of 1 divided by the square root of 4. And the square root of 1 is this one, and the square root of 4 is this 2. One way or another, you get 1/2 here, and -3/4 times 1/2 is -3/8. So -3/8 is the output, while 1/2 is the input. 3 is not too dissimilar from 2, except now that instead of being told the input to our function 1/2, we're being told the output for our function -6. So I again take this function here, f of x equals -3/4 times 1/4 to the x power, but now instead of changing the inputs into 1/2, I'm going to set the output equal to -6. So I'm going to say this -3/4 times 1/2 to the x is equal to -6. And now I want to get this x all by itself. Well, that's really hard to do. In fact, we don't even really have the machinery to get this all by itself just yet. But I can figure out what this x is equal to if I can at least isolate this exponent. So maybe I'll get rid of this -3/4. You could divide both sides of the equation by -3/4, but I think it's easier to multiply both sides of the equation by -4/3, which is the reciprocal of this guy. If you have a -4/3 here, the 3's cancel, the 4's cancel, and you're left with just 1/2 to the x power on this side, and then the -4/3 appears over here. So now maybe I'll simplify the right-hand side a little bit. I got 1/2 to the x power is equal to, well, -6 times -4/3. Maybe it'll help to think about that as -6/1 times -4/3, and then multiply straight across. Negative 6 times negative 4, a negative times a negative is a positive. So I get 24, the product of 6 and 4, divided by 3. And 24 thirds is just 8. So I get 1/2 to the x power is equal to 8. So what is x? Well, if you're really good with exponents, you might be able to just look at this and tell what value it is. But as far as methods for actually solving this, the only method that we've seen is the one where you equate the bases. So you're thinking about, all right, what base can I choose so I can write 1/2 as that base raised up to a power, but can also write 8 as that base raised up to a power. And there's lots of different options you can choose. I think 2 might be the easiest. 2 to the negative 1 power is the same as 1/2. So I can rewrite 1/2 to the x as 2 to the negative 1 to the x. And 8 is the same as 2 to the third power. So I can rewrite this side of the equation this way. And when I raise exponents up to exponents, I multiply them together. So I get 2 to the negative x is equal to 2 to the third. And now that I've equated the bases, I can equate the exponents and say negative x equals 3, and therefore x is equal to negative 3. Oh yeah, that makes sense. If you all go all the way back up here, if this were negative 3, the negative would mean take the reciprocal, so this would flip this upside down, and it would become a 2. And then the 3 would say 2 cubed, and sure enough, that is 8. And then finally, question 4, we're supposed to sketch an approximate graph of this function with an emphasis on the word approximate. Let's see, what I would do is I'd first look at this and figure out the value of a is negative 3/4, and a always tells me my y-intercept. So somewhere down here at about negative 3/4, my graph should go through that point. And then I think about this 1/4, and that's telling me how much I should multiply by each time I take one step to the right. So negative 3/4 times 1/4 would give me negative 3/16. So I'm getting really close to the axis up here. That's not super helpful. Well, what about if I took a step to the left? Well, if I'm taking a step to the left, I'm dividing by 1/4, which is the same as multiplying by 4. So if I take this negative 3/4 and multiply it by 4, I get negative 3. So the height at negative 1 should be down here at negative 3. That's a little bit more useful. I think with these points, I can go through and I can kind of sketch a curve that has approximately the right shape. Note that we should have a horizontal asymptote as we go out here to the right. Maybe we can call this good enough for our graph of f. And since that's the last thing I was supposed to do, I guess that's the end of these solutions.